Hello, chemistry students. We are going to go through a couple of things in today's lesson. Hopefully everything went well with combining ions that we talked about right before break. So today we're going to hit on a couple of things. I'm going to show you how to represent elements and ions with electron dot structure. I promise it's super simple. And then we're going to go through how to combine polyatomic ions, which are obviously a little bit different than the binary ionic compounds that we talked about. So this is going to be a little more complicated. So kind of that next step, if you will. So when we do combining of ions, we want to make sure that we're using the common ions handout that you either got in class or it is posted on the hyperdoc for this unit called Common Ions Handout. So it looks like this. So this you needed in order to complete the worksheet from right before or yesterday. It would have been the worksheet yesterday. Sorry, I was out yesterday. So this just shows all of that. So here's all the ions with a +1 charge, +2 charge, and +3 charge organized that way. And then elements with -1 charge, -2 charge, and -3 charge. So for yesterday's worksheet, this is all you've needed is we were doing monoatomic ions in binary ionic compounds. We only use this top part. For polyatomic ions, we use the bottom part and the top part actually. And so I think the difficulty with polyatomic ions is when you see a group of ions together, like a bunch of elements together, you kind of have to be able to recognize that we're talking about an ion like acetate, for example. So the first thing we're going to work on really is just, I'm going to give you the ions and you're going to combine them. There was an error on this second one, so just so you know, like that has been rewritten because it was wrong on this sheet, which is just copied from a book. But anyway, so these also are organized by +1, -1, and then we have -2, -3. So polyatomic ions, these are charged as a group. So acetate, for example, is C2H3O2 with a -1 charge. But it's this whole group together that is charged as a collective group. So a little bit more complicated that way because here you're dealing with individual atoms of an element, and here you're talking about these things are grouped together, but then as a group have that charge. So it becomes a little more complicated to represent. So we want to go kind of through that. Do not look at numerical prefixes yet. That is actually for the next chapter. This has nothing to do with ionic compounds, but we need it when we talk about covalently bonded compounds. So ignore this for now. Please don't try to use these yet. I promise they're super fun. We'll get to use them in the next chapter. All right, so electron dot structure. This is really simple. I'll just go through this really quickly first before we get into combining those polyatomic ions. This is like a 5-minute thing. So, electron dot structure. So, electron dot configuration is a way for me to represent those valence electrons. So, for example, chlorine has 7 valence electrons. I should be able to look at the periodic table. Let me bring that up for you really quickly. And see chlorine is over on the right-hand side, right there. And if I want to write the electron configuration for chlorine, I can start from neon, which ends in 2p6, but I can do neon, and then it is +3s2, 3p, 1, 2, 3, 4, 5. And when I'm talking about valence electrons, remember, I'm only looking for that highest energy level. So really for this, it is the 3. So it's this 3s2 and 3p5. Remember, neon ends with a 2p6. I don't care about the second energy level. I care only about the third energy level. So chlorine has 5, 6, 7. And I also would know that because remember, as we go across the periodic table, these all have 1 valence electron. These have 2. I have this written on here. Most of these have 2, although there's some that have multiple variations. Everything in this row has 3, 4, 5, 6. Right? Halogens have 1. And then the noble gases all have 8 valence electrons. So how do we represent that? So chlorine, I'm going to put dots around it. It's really that simple. It's 1, 2, 3, 4, 5, 6, 7. I have a little bit sloppy here. Straighten these out because their location does matter. So the format we use. So this represents, yeah, chlorine has 2, 4, 6, and then 1 more is 7. Valence electrons. If X is a fictitious element, so I'm just showing you the order that we fill these is upper right is first, lower left is second, top left is the third electron represented, the lower or the bottom right is the fourth, and then we go, so now I'm at 4, the fifth one is here, 6, 7, 8. So jot that in your notes so you remember the order. Your book is a little less specific, but I'm the old school right, left, top, bottom, right, left, top, bottom. So each side, so if I'm doing this, right, left, top, bottom, right, left, top, bottom. Notice that this is more of a box, if you will. What you should not do with these is just start going around in a circle here. It's not a circle, it's a box, and it matters, okay? Also when you're writing these don't put just a dot at me, I can't tell if that's there really or not. 1, 2, 3, 4, 5, 6, 7, 8. These represent pairs of electrons. There's a pair, there's a pair, there's a pair, there's a pair. And they are on the sides, tops, and bottoms. They are not in a circle orbiting around this element. So when you draw these, just make sure that you're doing it that way. That's the right way, and there's a reason for that. Because they are pairs, and they should be represented as pairs. All right, something like potassium, if you look at where potassium is on the periodic table, it's in this first column. Potassium is right here. So potassium has 1 valence electron. So potassium has just 1 dot. So if potassium and chlorine combine, potassium is going to fit right there, and it's going to donate an electron to chlorine. Chlorine becomes filled with a valence electron, and because these represent shared pairs, and we talk more about that when we talk about covalent bonding, but I want you to understand the electron dot structure. If an element has 2 valence electrons, 1, 2, like that, and so forth. So we'll practice that, but I wanted to just give you a quick overview. So that completes electron dot structure. I'm actually going to go through polyatomic ions in a separate video because I can see that I probably won't have quite enough time to really do a good job with that here. So this is electron dot structure.